Great. Welcome back, everyone. I'd like to start our afternoon session with videos from our sponsors. Thank you very much. I am very excited about the panel that we have this afternoon about technology as a game changer. I think we all pretty much know, because probably somewhere in your hand right now is an iPhone or an Android or something, just how essential technology is to our everyday lives, and also how essential it is to tackling some of our world's problems and challenges. You know, ocean observations are crucial to predicting weather, climate, tides, and to prevent illegal activities on our seas, such as illegal fishing. Investments in new technologies by the private sector are game changers for our oceans. And I'm very excited to welcome this afternoon Bill Hilf, who serves as the Chief Executive Officer for Seattle-based Vulcan. As Vulcan's CEO, Bill works to translate the vision of Microsoft's co-founder and Vulcan chairman, Paul Allen, into results that strengthen communities and improve our planets. I'll have to admit, when I read his bio, I thought this was the coolest job ever. He uses his experience as an executive and technologist to lead Vulcan's work to tackle ambitious challenges, like the ones that you saw in the video, head on, and to guide its growth and invest in catalytic philanthropy, scientific and technological breakthroughs, and inspirational experiences. Most recently, Bill served as the Senior Vice President and General Manager of Hewlett-Packard's Enterprise Cloud Business Unit. And prior to joining Hewlett-Packard, Bill was the General Manager of Project Management for Microsoft Azure. We are so incredibly lucky to have Bill here this afternoon as such a visionary for both our oceans and for the use of technology in terms of conservation. So without further time, I will turn the stage over to Bill.
Thank you, Chris. Well, good afternoon, everyone. It's good to be here. Typically, for the past 20 years, I've spent time in front of audiences that were all technologists and geeks, and most of them staring into their phones or laptops. So it's really exciting to have people looking at me in a presentation. It's thrilling. So it's an honor to be here and spend a little bit of time with you talking about some of the work that we're doing at Vulcan. And I'll give you a few examples of some of the projects that we're working on. And really, I hope that you can understand how we believe that these public-private partnerships and the use of advanced technologies and data and science can really help us change the game in how we're protecting our oceans. So first, let me give you a little background of what it's like to work at Vulcan. My boss, Paul Allen, we typically start off our weeks asking questions like this. What are some of the world's hardest problems? Sometimes every day we ask ourselves these types of questions. And we typically try to think about technology and sciences as our ways in, or ways to approach solving some of these tough problems in the world. And one of the great opportunities that we have is we're able, as a private company, to take some very unconventional approaches and move very quickly with our experiments. As you all know, illegal fishing is a threat to our oceans as well as to global and economic security and health overall. So we've been taking a hard look at that, driven by Paul's vision to really look at how we can use technology and data to improve the situation related to illegal fishing. So we've turned, our our sights, so to speak, onto this subject. I'll talk specifically about some of the things that we're doing. And we really do believe that there's a crisis happening in the oceans, and it's one of the areas that we think that maybe the only way to solve the problem, because of the complexity, because of the size, because of the variability, we think that technology and science and data are going to be required in order to really crack this problem. So let me explain a little bit about what Vulcan is. You may have heard about us or seen about Vulcan. What we are sort of technically is a holding company, but it's really Vulcan's the engine behind a network of organizations and initiatives. And really my primary job is to translate Paul Allen's vision into impactful results that help improve the world. So who are we? Well, like myself, there's many technologists, there's engineers, there's scientists, entrepreneurs, filmmakers, investors, and philanthropists. We have a really unique organization with a variety of different backgrounds and disciplines that we bring together in a variety of different pursuits. We work on brain research. We have a large brain research institute in Seattle. We're based in Seattle. That's where I get this incredible suntan from. I know you're looking at me saying, how does he get that tan? We spend a lot of time on artificial intelligence. We have a whole institute dedicated to artificial intelligence. I'm going to talk a fair amount about AI and machine learning this morning or this afternoon with you. We work a lot in biodiversity, in wildlife conservation, and in oceans health. We spend a considerable amount of time on climate issues, homeless issues, pandemic response and detection. And yes, we do some things in sports too that you may have heard of. We have a couple teams in the Northwest that Paul's really fond of. And believe it or not, we use a lot of technology there as well. So kind of our superpowers or our core muscles are in science and data and technology. Now, one of the things I think is illustrative of what Vulcan does in this area is it's a good example of how a private company can come in to a space that's complex and bring a mix of resources to bear and move very, very quickly. And that's something that we believe is critical in some of these more complicated areas in conservation. As a technologist, I've spent 22 years in technology, and one of the things that has helped me succeed throughout the different places I've worked is moving very quickly. You can't survive long in a technology business if you don't move quickly. However, we've all used, maybe you're using right now, technology that's very limited or brittle or unsatisfactory or incapable. So building technology in a way that is on a stable platform that can then really grow over time and scale over time is very important in how we approach things like our illegal fishing project I'm going to talk about in a moment. And most importantly for us in this area is we have a long-term vision and a commitment to oceans health. And we know that to have any sort of enduring change in an issue like this, you can't just be an experiment or a stunt. You have to continue to iterate over time, improve what you're trying to work on, and see that to its long-term vision. So one thing that I've learned throughout, particularly my career at Microsoft, is about integration. And I'm going to talk a lot about why we think integration is very important. I do believe that integration is a critical form of innovation. And what I mean by that is integration of technology, making sure technology can work together seamlessly. Integration of data is extremely important, and I would say on many fronts, conservation being one, global security, national security being another, where you're seeing increasingly every day the threat vectors grow in a matrix and growing in a much more complicated way than they ever have before. And this is true also in oceans health. So being able to integrate multiple types of data streams and be able to reason over that integrated data is very, very important. And the second piece of integration, which often people forget, and some of you may blame me as a former Microsoftie for occasionally forgetting this in some of the Microsoft products, is integration with the user. Making sure that whiz-bang technology, that new data, the new trinket, the new gadget, is actually integrated with the user and the customer. And in many cases, particularly some of the things I'll share with you this morning, some of those users that we deal with are not technically sophisticated. Some don't even have a primary education So how do you build technology that's accessible to a broad audience is very, very important. So let me give you some examples. I'm going to do a little bit of a toeth by land on you here. I'm going to give you some examples of things that we've done in Africa, and I'm going to use that as sort of a springboard to explain what we're doing in the oceans. There's a technology that we've built called a domain awareness system. We call it DAS for short. It gets a little clunky to say domain awareness systems many times throughout the day. So basically what we had is a situation in Africa where there's large land masses, large parks that were very complex, vast territories, limited resources, and we were trying to find a way to capture and deliver real actionable data, not just to identify or make aware what was happening in that environment, but also to create the empirical evidence for enforcement. Because I think one of the missing links that I've seen frequently in the broad philanthropy space is that coupling from identification and awareness to action and enforcement, and that's crucial. We believe it's particularly crucial in the oceans. So what this does, this domain awareness system, it integrates a variety of types of data. Data from radios, from airplanes, helicopters, sensors on gates coming in and out of a large park, and these parks are large, 40, 50,000 square kilometers. Data from animal callers on elephants and cheetahs, and data coming from people making reports just driving around. We pull all that data together, and we create this integrated visualization platform, and a platform that you're going to see a user here actually interacting. This is one of our park rangers interacting with our domain awareness system. All the things you see on the right are the events that are being reported. Gates being open, animal carcass being identified. You'll see in a moment here, this ranger is working out of an operations center, and he got a radio call about some road banditry that was identified, so he'll log that in. And what it's doing is capturing data from all over and bringing it together in one spot. So why is this a game changer for what we're doing in Africa? It's taking what had been binoculars and Land Rovers and paper pads and radios and bringing now modern technology with lots of data coming in an integrated way into an operations center. So these park rangers can now manage animals that are threatened and to go and intersect and interdict where they believe the bad actor may be. So this is one small example of something we've done. Well, by the end of this year, we'll have close to 90,000 square kilometers covered in multiple different parks with, this is in northern Kenya in the Liwa Valley, covered by our DAS system. So let me give you one more example of something we're doing in Africa, where we're using drones that we make at Vulcan, fixed-wing drones, and we build those with high-definition cameras and artificial intelligence software on board the drone to identify what poaching activity. And so there's sort of a subclass of artificial intelligence called machine learning. You may have heard this phrase a lot, where we use a lot of machine learning to identify patterns in data. If we identify canoes or trucks or people walking or animals, and we identify the anomalies through that data. So when the drones are flying over, they can identify things like you see on the right here. I'll give you a closer picture of it. This is from just 4 weeks ago, where it identified a campfire that turned into a bushfire. And campfires are a common sign of poaching activity. So this allows the rangers in these parks now to do, these are hand-thrown drones. They throw them up in the air, they take off, and they run in a semi-autonomous grid pattern, kind of like a zigzag pattern. So they're not flying them like you would like a helicopter drone on your own. They run on their own, and they're sending back a live feed as well as using machine learning software over that video as it's traveling over that pattern, looking for those anomalous behaviors. So again, going from binoculars and radios to artificial intelligence and drones. It's a game changer for these rangers. I mean, it's not a generational leap technologically. It's an order of magnitude increase in what they're able to do, the amount of land that they can cover, the things that they can identify. Software being able to identify anomalies faster than they could by radio and binoculars. So it's a very powerful thing. We continue to do this throughout Africa. We have a lot of plans for this going forward. So what about our oceans? And if you think about sort of the thread that what I'm trying to illustrate here, it's this integration of different types of data streams, integration of new types of technologies like machine learning and artificial intelligence, and with the goal of being able to cover large areas and have smarts in the device to identify the problems. So a couple years ago, we started a project where we have a team where we have an aerospace group at Vulcan. You may have seen the tiny plane that we announced a couple of weeks ago or last week. It was a little bit in the news. I'm being facetious. It was a very large plane. It's called Stratolaunch, but we have a whole aerospace group. We have experts in maritime security. We have conservation experts. We have government affairs teams and policy experts. And of course, we have our tech dev team. So we brought that whole group together to say, how can we approach this illegal fishing problem? What can we use to go after this? And again, it came down to taking advantage of some of the newer technologies like computer vision and artificial intelligence, but integrating that with something that a government could use or get alerted to when anomalous behavior shows up. So our goal is really having fast data that leads to fast intelligence and then all the way through to fast enforcement. We do not think it's sufficient just to have a website with information that shows where data may have happened. We want people to get arrested. We want boats to get pulled off the water. That's what action looks like. So that was our goal when we designed this project. We call it Skylight. There's our very, very high-tech logo. Took a long time to build that one. I'm just teasing my graphics team. They did a great job. But our project, basically, I'm going to show you a little screenshot of this. This is something that we're working on actively, and we're working with quite a few different people around the world on rolling this out. So here's a quick peek at a screenshot. I don't know how well you can see that. Yeah, it's pretty good. Where you're basically seeing a bunch of fishing vessels off the coast of Brazil. You can actually see it better up there than I can see it down here. And you can, select a particular boat, and it'll give you a little baseball card up there. You can see this Chinese boat up there, the Changrong 3. You can track it. That's AIS data that it's being tracked. You can see it's doing this fishing activity in the high seas right there. Then it starts to move into this Ascension Island EEZ, a developing area where there's not supposed to be any fishing. Now, frequently, so this is great. We can track this using this type of data, AIS data and other types of data, what I'll call conventional ways of tracking. But more importantly, we can start to use machine learning over that data. So what we can do now is say, let's now look, machine learning is basically software that learns from looking at lots of data. So rather than programming the software to do every little thing yourself, the software learns from eating up large amounts of data and is able to predict more accurately. So we can run machine learning over all of this and say, what does this boat do over time? What's its typical pattern? And we can grab a bunch of information about it. Its license information or lack of license information, its background. Then as many of these boats, as we know, will then, as they start to get into these areas that they know they're not supposed to fish in, they'll turn off their AIS data, and they become then a dark ship, and they disappear. So that's not sufficient enough to have action. We can't have a system that just relies on data that, it's kind of like being able to reach into your car dash and when you're speeding, just turn your speedometer down to 30 while you're going 70 miles an hour. Doesn't seem fair. So we're starting to integrate other types of data. So we also invest in a variety of different satellite companies. And so we're starting to use that satellite imagery and data and those technologies integrated into this system. So when these ships do decide that they want to go dark, we'll have other ways to identify where they're at and importantly, to be able to take pictures of them. And as it comes down to enforcement, and being able to go back to the Brazil Navy or to the US Coast Guard to say, what is it that we need to take this all the way through? It's that sort of data set that we are hearing from our customers could be very, very important. So this is the start of Skylight that you're seeing. Our booth out there, we have lots of experts who can talk more in depth about it, and we're very excited about what we're doing here. So again, our primary goal with all of this work in Skylight and other things that we're doing around in Ocean's Health is really to get faster, actionable data that allows for on-water enforcement. So our key performance indicators, because I do run Vulcan like I run a technology business, so although not everyone appreciates that sometimes in the broad philanthropic world, but I think it's important that you measure what you're investing in. And so we do measure this very closely. We measure it like as boats being taken off of the sea, illegal fishing boats that are being pulled off the water. That's one of our top KPIs, and we think that's very important that we keep our eye on the prize of enforcement all the way through that chain. So it's really, you know, with partners in the room here and around the world, we think by taking advantage of technology, taking advantage of data and science, that we can, as a community, create the conditions for much greater economic development in our oceans and restore oceans' health, and of course, importantly, enhance our global security. So I'm very excited to be part of this. I'm excited to be here talking to you all, and I just want to say thank you very much, and you can look forward to a fantastic panel that's going to come up here right afterwards. Thank you.
Bill, thank you so much, and to all the great team at Vulcan for putting technology to use for conservation in our oceans, especially around such an important issue like illegal fishing. Now, let's take a little bit deeper look into the issue of technology. As we've talked about, recent developments in technology are improving business and environmental planning, providing early warnings for water quality risks to humans, and leading to new discoveries and detecting illegal activities. Our moderator and panelists this afternoon will explore ways we use technology in ocean science, conservation, and protection of our underwater resources. First, please let me welcome our moderator, Shaw Selby. Shaw is an engineer, conservation technologist, and National Geographic emerging explorer. And in his spare time, he works on technology that helps protect marine protected areas, fights illegal fishing, and cleans up oil spills. Is anybody getting the impression maybe we're a little bit of underachievers if we're not in the technology world? But Shaw, thank you so much for moderating this panel. And panelists, please come on up. So let me just do one quick reminder too. Please know if you have questions for our panelists, please use the comment cards. Feel free to pass them to our volunteers and staff. Or you can use Twitter at Marine Sanctuary at hashtag #Chow2017. Thank you very much, and I'll turn it over to Shaw.
Thank you. Hi, everyone. I'm excited to lead this panel today with these really great panelists. I think there's a lot of exciting stuff happening in the technology world, and hopefully we'll be able to explain that excitement to you guys as well. So I'll first introduce myself, and then I'm going to go through and introduce all the panelists, and then we'll go through some questions that I have for them, and then open it up to audience questions. So as was said, my name is Shaw Selby. I call myself a conservation technologist. I basically work at the intersection of conservation and technology. I'm a fellow at the National Geographic Society focused on that sort of work, and I have a nonprofit lab in downtown LA where we build all that, lots of different types of tech and send it out. So some of the projects we're working on there is we just recently got some NOAA funding to do a low-cost CTD device. We build acoustic buoys that use machine learning and some other information to try and find vessels in places that they're not supposed to be, and some other technologies like that. So I'm going to read the introductions for these distinguished people because I don't want to mess up any of the great achievements that they have. So first is Keith. Keith is the Executive Director of Technology Advancement at Vulcan. So Vulcan's technology advancement takes on some of the world's most difficult and important challenges and develops future technologies that can improve human lives, protect the environment, and advance frontiers of science. Before joining Vulcan, Keith was the Director of Research at Intellectual Ventures Laboratory, where he managed startup projects and intellectual property discovery. Keith began his career as an applied physicist and planetary radar astronomer at NASA's Jet Propulsion Laboratory, the Deep Space Network, and Arecibo Observatory. Keith holds a bachelor's degree in applied physics from Caltech. So next I'll go on to Jyotika. Jyotika is the Senior Director of the Planet and Environment at the X Prize Foundation and the prize lead for the Shell Ocean Discovery X Prize, which is a $7 million global competition to accelerate innovations in underwater deep sea robots and artificial intelligence for high-resolution ocean exploration and discovery. She joined X Prize in 2014 as the Technical Director for the Wendy Schmidt Ocean Health X Prize, which was a competition advancing pH sensor development to measure ocean acidification. She's got a PhD in physical oceanography from the University of South Florida and an MS in atmospheric science from SUNY at Stony Brook. Next, I'll go on to Mario. Mario is the director for the Alliance for Coastal Technologies, which is part of the U.S. Integrated Ocean Observation System. The Alliance for Coastal Technologies is funded by NOAA and EPA to foster the development and adoption of effective and reliable sensors and platforms for studying and monitoring ocean and coastal freshwater environments. He received his BA from the University of California at Santa Barbara, an MS from University of Alabama, and PhD from the University of South Carolina in biology and marine science. And last but not least is Roger Hine. Roger is one of the founders of Liquid Robotics, and he's the primary inventor of the technology. So he's a mechanical engineer, a robotics expert, and an entrepreneur. Prior to forming Liquid Robotics, he directed robotics and automation technology development programs at a leading semiconductor equipment manufacturer. And he has a Bachelor's of Arts in Economics from Wesleyan University and a Master's of Science in Mechanical Engineering from Stanford. So these are really, really great people in terms of this discussion today about technology and the future of technology in the oceans. So I'm going to start out by asking each one of them a question, and then we'll go on from there. So let's start with Keith. Vulcan has been and kind of continues to be at front and center in this space of technology innovation and bringing much of the stuff that we heard earlier to light in recent years. So I'd like to hear your thoughts on kind of the current broad technology landscape and how the private sector can help out.
Wow, great question. So you're right. You heard Bill say that his job is to talk with Paul and figure out what the world's hardest problems are. The next step in that sequence is he usually calls me and says, okay, what are you gonna do about it? So yeah, we spend a lot of time looking at different kinds of technology, and that's what my job at Vulcan is to identify lots of different kinds of technology and figure out how we can bring them to bear against whatever problem we have. So, it starts with how do you get data? Sensors, we hear about the world of IoT, you talk about buoys and things like that, so there's lots of environmental sensing kinds of things. There's active sensing, like the AIS data we see on ships that's put there expressly for the purpose of doing that, as well as camera technology on boats to monitor what kind of catches are coming in. There's satellite technology that's coming more and more available. We used to have only very big, expensive satellites in orbit, and even now that data is very good, but also very expensive. But more and more you're seeing new companies like Planet, like Dark Sky, Black Sky, putting constellations of small satellites in orbit that provide a lot more imagery and data more accessibly to people who want to get involved in that. After you have all that data, then you have to integrate it. So that's where machine learning, advanced analytics, something some people in the audience may care about is data standards and how to unify all that comes together. Bring all that together, perform useful analysis on it, and then finally deliver that to the end user in a way that works for them, as Bill said, for enforcement. And I think that's where all the partnerships come together is how do you find all those touch points, bring them together, how do you work with governments to make sure that they get what they have, how do private entities figure out how to work with nonprofit entities to address the issues of data standardization, privacy, security, data flow, and eventually enforcement and change.
Great. I'll go to Jyotika next. So, at XPRIZE, they like to talk about this. We live in this era of exponential innovation, right? So this is the idea that technology advancement and the capabilities that we have today just keep on getting better and better because we have better technologies and they build on them and things happen exponentially. So, I would maybe like to hear your thoughts on exponential innovation in this space. What are some technology innovations that you're excited about, and what kind of challenges do we have to push this forward in the whole respect of exponential innovation?
Great question. So we talk about exponential change, which is essentially following a Moore's law kind of curve, which we've seen with computer technology, we've seen with data storage technology. So there's some really interesting exponential technologies that I think we can really more adapt and pull into the marine realm. For example, 3D printing. That's going to revolutionize manufacturing. It's going to make things a lot cheaper. So that's certainly one example. Another example, of course, is robotics. So the Shell Ocean Discovery X Prize is essentially an underwater robotics and AI competition, so artificial intelligence, which Volkan's also talked about. So that's another area where I think we're going to see huge advances. And then in sensor development, I think sensor development is advancing in leaps and bounds. It's not so much the large instruments that we used to have when I was growing up in oceanography, but sensors are getting smaller and smaller. In the Wendy Schmidt Ocean Health X Prize, we had a pH sensor that was in a case that was as big as an iPhone. Imagine if that's how big your oceanographic instrumentation was and how much you could get out there. And I mentioned robotics, things like swarm robotics for the marine realm will be really, really fascinating advancement. And I think you asked about what some of the challenges are. So I think there are three main buckets. One is the data, which we've also talked about. What are we going to do with all this data? How are we going to combine it, adapt it, use it? And I think with the advancement of machine learning and also artificial intelligence, that's going to help us enormously. And I think another challenge is funding. So the funding to develop prototypes and then to test them and then to take them from that prototype stage to mass use is another big challenge that we have. And potentially the third one looking forward is regulation. The regulations that we currently have may not be as useful as technology changes. And I'm looking at an example in the air. So drone technology has advanced enormously in the last 2 years, and the FAA is struggling to keep up with that kind of technology as it becomes more ubiquitous. So I think we should start looking at what technology is up and coming, and how is that going to impact regulation.
Yeah, that's, and I have some questions that I wanted to talk about those challenges specifically, because I think there's some lessons in the general technology landscape, and we can talk a little bit about that. But I'm going to move on to Mario. So the Alliance on Coastal Technologies has done this well, but I'd like to hear your thoughts on approaches for stimulating or facilitating ocean technology innovation.
Right, thanks, Shah. I think there's been a real shift in how we think about new ocean technology innovations. I grew up in a sort of world where those technologies developed through a very academic process, where an agency would see a need and they'd release a call for proposals, and they would fund 2 or 3 professors at universities to develop a new technology. That's really changed over the last 10 years, almost turned on its head with efforts like the X Prize, where the funding doesn't come at the beginning, the reward sort of comes at the end. And I think it's made a big impact on technology development in our area in ocean technologies. One example is a program that ACT helped run with a variety of different agencies called the Nutrient Sensor Challenge. What happened was about 4 or 5 years ago, the White House Office of Science and Technology Policy brought together a variety of agencies working on environmental issues, and they asked them, what's a big cross-cutting issue that you all have to deal with in some way? And what's the biggest limitation to solving that problem? Very similar approach that we heard earlier. And what they came up with, nutrient pollution, is a big issue that they all have to deal with. This is EPA, NOAA, USGS, USDA, NIST, and others. They're all dealing with nutrient pollution, whether it's from ag issues to dead zones in the Gulf of Mexico. And what they identified as the biggest challenge to overcome that issue is the lack of technologies, lack of instrumentation to measure the nutrients, nitrate, phosphate, and others, in the water. Instruments existed, but they were very complex and fairly expensive. And so it was prohibitive to use them in the appropriate spatial and temporal resolution needed to answer these questions. Where's the nutrients coming from? How is it impacting the environment? So they came to ACT, and as a group, we put together this challenge to help incentivize these new next generation of nutrient sensors. But unlike the X Prize, we didn't have a big monetary reward at the end. There's no big $1 million check. So we turned it into a market stimulation challenge. And the reward, essentially, for the research and development into these new instruments was the market. So we worked really hard to identify user needs, the different potential users from industry to things like aquaculture, resource management, and so on. And we're able to identify that there are thousands of users out there that would love these technologies if they existed. And these technologies are a little bit better in performance, a little more accurate, a little bit more precision. But the big change is the cost, driving the cost down from 20 or 30,000 to below 5,000. So we launched the challenge. We had about 30 registered participants at the beginning. We whittled it down to 6 teams at the end and went through a variety of tests of their new next generation nutrient sensors, and were able to award the winners, announce the winners earlier this year. In this short period of time, we've changed the technologies that are available to us to monitor nutrient pollution, but we didn't stop there. It's great to have these new tools, but we need to move them into operations. We need to get them in the hands of users. So we're following on the Nutrient Sensor Challenge with what's being called the Nutrient Sensors in Action Prize, where agencies like EPA, NOAA, USGS, and others are putting together some resources to fund teams, users of technologies, monitoring programs, and the developers of these next generation sensors to team up and actually incorporate those new instruments into a monitoring program, collect data, make decisions based on that data. So it's sort of an end-to-end process, not only fund the development, but also support its transition into operations.
That's great, yeah. I want to add a little bit on there too, because this is something that my work focuses on specifically. I think the concept of open source has also helped a lot of just general technology development. So Jyotika mentioned drones. Drone technology moved forward because a lot of that stuff was done within the open source hardware community. So these ideas are coming from people that maybe aren't backed from a major university, or maybe they're not backed by a corporation or something like that, but they're just enthusiasts that are getting out there, understanding the problem and developing stuff. And I know a lot of the people who end up going to enter things like the Nutrient Sensor Challenge or some of the X Prize competitions are folks that were working within the open source world and oftentimes continue to keep their technology open to people, to anyone who wants to use it. Next, I'll go on to Roger. So I think Liquid Robotics has some interesting insight into this, into how you can take a single technology and leverage it across multiple different users and meet the needs of different organizations. So I was hoping that maybe you could talk to us about, how your technology has really done that with maybe the defense industry and the academic world and ocean science, and how you can kind of navigate that space.
Yeah, so I think that, first off, I think that robots are going to transform the way humans interact with the ocean. But for them to be able to do that, they have to overcome a few barriers, and one of them is just reliability. And so I think ocean robots are actually a very popular topic in universities, and it's wonderful. But really, to get to the stage of being operational, you have to go beyond that and work out the kinks over thousands of miles and many years of operation. And so it's one place, I'm a big believer in open source, but I think actually in this case, it's really, you want to have something that is a little bit more focused. And so our strategy was to really focus on that robot and apply it to a wide range of applications. So we work with industry partners that are expert in their field, while we focus on just building that reliable, lasting robot that can really live in the ocean and support a variety of things. And so we've really, the way I've looked at it is I've kind of divided our customer base up into 3 main groups. There's the defense community, security and defense. There's commercial, which is primarily oil and gas. And then there's science and environment. I put those 2 things together. And I think that we would not have been as successful as we have been if we hadn't had all 3 of those sort of pillars going at the same time. We wouldn't have been able to survive with any one of them taken out. The science and the environment is what really drives a lot of us. It drives me. It's what we emotionally want to be able to do. It's where I think our technology ultimately will have the biggest impact, is in understanding the planet. But I don't think we would have been able to finance it otherwise, without having the commercial and without having the defense pull. The U.S. government and governments around the world continue to spend quite a bit more on defense than they do on civilian applications in the ocean. And we found a really good technology fit where we can have a compelling advantage to the warfighter. The oil and gas industry likes to say sort of out of sight, out of mind. Every once in a while, something like the Deepwater Horizon brings them well into sight. But it's an enormous industry that's operating offshore and employing tremendously advanced technology. Sometimes I think it's funny going to Houston from where the Silicon Valley is supposed to be the center of tech, and you look at what these guys are trying to figure out how to do. It's phenomenally advanced. And so they've also been driving technology forward. And so we've had a strategy of sort of, we're going to support all of that. We're going to focus on what we need to figure out how to do indispensably, which is build a robot that lasts, and work with partners who then add content on top of that.
That's great. So now I'm just going to open it up to whoever wants to answer from the panel. I want to get back to talking about maybe some of these non-tech development challenges that you face with the technology. One of those is funding. So funding has been an issue for these sorts of projects in the ocean realm because this kind of technology development, the way that it happened when it came to oceans was very specialized, right? It was developed by a government organization or working with an academia, and the scaling and incubation and the changing of that technology has not been in the same way that we see in some other parts of the tech sector. So I'd like to maybe hear from you guys what your thoughts on funding and scale in relation to ocean technologies is.
Right, I'll start then. I think we're seeing some really interesting potential shifts. I think having private companies, some of the big tech companies from the Silicon Valley area taking an interest is fantastic. I also, this morning at the UN Oceans Breakfast thing, there's a discussion on blue investment and blue bonds, and that's an up-and-coming area for financing. And then there's a whole host of incubators and accelerators that have popped up in the marine realm, which I think will also really boost the ability for the smaller innovators to really pull themselves up and out and into the business community. So I think there's some really great trends and shifts in that respect.
Great. Do you want to?
Yeah, I think, as I mentioned, the model of agencies sort of supporting this development is not necessarily sustainable. And so I think it's really market-driven, most of the technologies that we work with. Every time we talk to technology developers, they'll say things like, what you're asking for is not impossible. We can absolutely do that. We just have to make sure we sell enough. And selling a dozen to university professors is not going to do that. So one way to help stimulate that market is the regulatory side of things. Regulated markets often thrive, but there is that catch there that Jyotika was mentioning, and that is, we don't want the regulations to happen outside of the technology realm. We want it to happen together so one can inform the other, make wise decisions. But hopefully, through good ocean stewardship, some of these technologies can advance.
Mm-hmm.
Yeah, I think with this panel especially, you can see the United States is very good at investing in early technologies and inventing things. And I think that's a tremendous strength that we have, is that there is this enormous entrepreneurial spirit, and there are foundations like the X Prize and like Vulcan that are willing to take a risk and invest in really exciting and risky technologies. I think where we do less well, particularly on the environmental side, is operationalizing it. And we have a very risk-averse government, and it's understandable, but I think that's a real challenge that these technologies face, is that you have to actually be willing to take the risks even at a larger scale. And I think that given the challenges that the planet has, that humanity has, I'm just looking for more willingness to take those big, bold steps. I think it's Paul Allen is doing a wonderful thing with Vulcan. I think Elon Musk and Jeff Bezos and Richard Branson get a little bit more attention for their space activities. And I wish it weren't that way. I mean, space is wonderful, but the ocean is such an exciting frontier on this planet. And how can we think big about doing some really exciting things out there? I think that's a question I don't have the answer for, but you know.
You know, I'd really just like to second that. As you mentioned, we're definitely willing to invest the first dollar and push risks in technology to get to a point where they can work. But, you know, we do need follow-on partners also. And Vulcan looks for ways to make something live in the world and go on. And that means finding useful markets, but also finding good partners in the government and with other entities and figuring out how to work with those agencies efficiently and at scale to get something rolled out and get other partners to help take the risk load further on down the road. That's really important to us, and it's something we look at even when we start projects.
Oh, no, I was just going to actually follow on from that with the idea of taking risk as far as technology development goes. And at XPRIZE, we do have some great partners for that very goal. So for the Shell Ocean Discovery XPRIZE, of course, we've got Shell, which is, you know, oil and gas, but $1 million is from NOAA. So it's a really fantastic example of a public-private partnership where we're all working on that same common goal, and it is taking a risk, and it's also pushing the technology forward in leaps and bounds. So I think I concur with your comments.
Cool.
Yeah, I think, and you know, that actually leads me to something that I did want to ask about was, you know, in recent years, we've really seen this changing of the relationship between government and NGOs and tech development folks and all this stuff, right? There's more of collaboration and more merging together to work on specific projects. I think we saw some great examples of it in the presentation leading up to here. But I'd like to hear some of your guys' thoughts about how that's changing, how, you know, some NGOs are stepping up and taking more of a technical leadership, and some are kind of some, you know, government things that governments would have normally taken over in the past is being adopted by the private sector or even some of the NGO partners. But how do you guys see that relationship changing?
Well,
Slowly.
I think, so I'm going to change that slightly. It's not just NGOs. I think there's another trend is taking personal responsibility. And so, for example, I'll give you an example. We're working on a prize under development for clean air, you know, and particulate matter. And one of the questions is, can that be an individual's capability? Can there be technology that's developed for the individual? But we also see within the homes there are individual abilities to filter air and stuff. So I think there's a trend of individual responsibility in addition to government responsibility to take care of your own, you know, water and clean air, clean water, that kind of stuff. So it's not quite answering your question, but.
I might just add that I do see much more collaboration, not only between, you know, the private sector and federal agencies or NGOs and federal agencies, but even within federal agencies. There's this real push now, because some of these questions are so complex and technically challenging, that leveraging and synergy is critical to have some success. So I'm very encouraged by things like our Nutrient Sensor Challenge, where you had all the agencies in the room working together to solve a specific problem, using academia, working with the private sector, and so on. And that often wasn't common, you know, 10 years ago. So I think there's a real appreciation for these joint efforts that you described.
Yeah, I also want to talk a little bit about, you know, big data and the need for data and how that's kind of emerging in the ocean realm. It's an area where that kind of tech or that development hadn't traditionally happened. So maybe we'll start with what Vulcan's doing, but I'd like to get your thoughts on big data.
Yeah, you know, maybe following on a little bit of the last conversation, I think one of the things we're seeing is a lot of trickle down or outflow from the very large commercial operations that are working on things like big data and artificial intelligence to places where you can apply them in more niche places that technology is becoming increasingly available. So, you know, when you use Facebook and it recognizes your friends' faces on there, that's exactly the same kind of machine learning technology that we're applying to recognize things in the oceans. Bill mentioned our FinPrint project. That's a situation where, you know, sharks and rays are apex predators in the environment. They are key to keeping our oceans healthy. And we really know nothing about sharks and rays. We don't know how many there are. We don't know where they live. We don't know where they migrate. We just know nothing. We do know that they're getting overfished and disappearing. So that's a big issue. And the FinPrint project is a camera trap project that uses that same facial recognition technology to recognize sharks and rays. We know which sharks are where. We know where they've fed. We know where they moved to. It's the first really serious underwater survey of where that is, and we're working with researchers around the United States to do that. But it's a good example of where that technology can move from a place where it is to a place where it needs to be. The same thing with big data. How do you process and handle enormous amounts of data? You saw all the boats on the AIS plots. I'm trying to remember, we get thousands and thousands, I think between 5,000 and 10,000 hits a second from around the globe into our system right now. Just of where all the boats are, and you can't process that kind of information and link it up with other data streams without having the kinds of big data manipulation tools that we've been able to port out of some of the big exercises by Google and Facebook and Microsoft and things like that. So you see that technology outflow now. It's really, really helpful.
We're actually looking at big data in a slightly different way, and how can we make it accessible to the public through apps. So we're running an app development challenge right now, the Big Ocean Button Challenge, and it's a $100,000 competition, so small by XPRIZE standards, but it's for any app developer, whether you're in oceans or not, to develop apps. And we give them the data, here's all the ocean data, and they go out and develop an app that would be easy to use, just like any app that you want to use, that's useful, that may be fun, that may be a game, it may be interesting. So I think there's a way of using big data to engage the public in a different way in the marine realm. So for example, if you had an app and you just scanned, if you were on the beach and you just scanned it and it showed you what the bathymetry was like, it essentially removed the water. Or if you had an app and you scanned it and it showed you what sea level rise was going to look like. So there's really interesting ways of utilizing different marine data sources and trying to engage the public in different ways. So we're hoping to have some fun apps out there soon.
And I'll just add to the big data question, because I know a lot of people are thinking about it now. You know, the management, storage, integration of big data sets and diverse data sets is a big issue that needs to be addressed if we're going to use this information correctly. But the one thing I want to mention, I think that often gets overlooked when we're talking about big data like this, is data quality is often ignored. Just because a number is written down somewhere doesn't mean that number is right. There's an error bar always around those numbers. And so I would encourage all of us, as we're thinking about integrating data sets, don't forget about data quality.
I want to talk about small data too, but I think we're on the precipice of something, you know, really exciting, and I think that's Dr. Lubchenco spoke about this morning about, you know, we have a National Weather Service and we don't quite have a National Climate Service, but we do have climate models and we have weather models, and the space in between of these what are called S2S, subseasonal and seasonal forecasting, is actually the space that I think is most relevant to the economy and to businesses. And so you have this space where we have the opportunity with big data to connect models. If the ocean models can be connected with the atmospheric models, if we can actually sample the ocean properly, not drastically undersample it as it is right now, but pull these pieces together and build forecasts that are actually on quarterly and annual basis, which happens to be how businesses are run. Now you're going to have an economic pull for these data. Right now, weather risk management is the largest source of financial hedging in the world. Trillions of dollars are moved for weather risk management. And you basically just sort of place counter bets to cover your bets on it. But there would be tremendous value in having really actionable information about what's going to happen a few months out. And it's not just weather, earthquakes, tsunamis, all of the risks that the planet threatens us with all the time, some of which, by the way, might be getting worse now as we're changing the climate, or at least less predictable. The ability to predict the response to that, if an event happens, if that volcano does actually go, how will that ripple through? I think that this is a really exciting space. I guess it's on the chopping block from the NOAA's budget, but it just strikes me as having, maybe this data product has the most financial value of anything that could be produced. And so maybe there's a new economic model for how that gets paid for. I'm not sure.
Great. So you mentioned risks. I want to talk about maybe some of the risks around technology development. So I hear this a lot when I work in conservation work outside of oceans, but people often ask, well, if you develop that technology, can't bad actors or people use that to actually find the elephants or whatever it may be, right? So there's always this kind of balance between what we're building so that we can get better at keeping people from doing things they shouldn't be doing, and whether those people can use that same technology to one-up us, right? So I want to get maybe some of your thoughts on that in relation to IUU fishing and some of the other threats that we face.
Yeah, I mean, that's a key issue. It goes to that credibility part too, right? So data is important because it has to be credible, but it also has security and privacy concerns around that. We're a little bit familiar with that. As Bill mentioned, we also have a football team, and we do a lot of sports technology development, and also in that case, tracking where people in the sports are and their performance, their behaviors, how they compete against other people. Incredibly useful for training, incredibly useful for competition, also incredibly sensitive from a privacy and security mode. As you might imagine, there's lots of money and people who care about that. Same thing in IUU fishing or in poaching or something like that. You really want to expose, you want to shine a light on the bad actors and show where they are. You don't necessarily want to give away, this particular rhinoceros is over here this day and not here. And so you really have to leverage, advanced data techniques, primarily taken from medical kinds of record keeping. So you anonymize and you do privacy checking, you do generalizations on some of the data, and then you really want to shine a light on the people who are doing bad things in a very credible way. Mm-hmm. And so we're trying to take that kind of thing and bring it to the data. But that's the kind of thing where you also need partnerships with lots of other organizations. You need to be able to establish standards for data transparency and credibility. You need to be able to work and share data across boundaries. And that's an area that needs a lot of work right now. It really does. You probably do the same thing.
I can talk next.
Go ahead, we can go
doing
in
in order. Yeah, so I think what we've seen is if you democratize access to something, you actually unveil the bad actors. And so an example is Twitter, and looking at some countries that we'd had no idea what was going on in those countries until it became ubiquitous through technology that we could have that kind of access. And so I view it in the same kind of way. Is as technology evolves, it gets smaller, it becomes digitized, easier, cheaper. There are more people in it, but on the whole, I think it may be optimistic of me, but I think on the whole, people are good. And so you really do have more eyes on the issue, and so you do uncover the things that are going on that are not good. I think, for example, for the Shell Ocean Discovery X Prize, underwater robots, we've removed the need for ships. They're being launched from the shore, which will then make it cheaper to access the deep sea environment. So this now opens up for other markets to come into play, including deep sea conservation and environmental management through cheaper and easier accessible technology. So I think it's on the whole a good thing to push forward.
Yeah, I'll just echo that. Thinking like a biologist, very much like, coevolution between a predator and a prey, right? They're trying to outdo each other. Can poachers get their own drones? Probably, but as Jodiko was saying, and as a whole, transparency, I think, is what helps the right outcome sort of happen. So I think, and if we keep advancing technology, staying one step ahead of the bad guys, maybe we'll have some success.
I think one of the things that gives me hope in terms of fishing is that it's maybe one of the unusual type of environmental problems that has a win for everybody when it's done right. I don't think that there's a good answer for the coal miners, actually. I think that's the on the other hand, it's a type scenario. There just really isn't a long term for coal as an energy source. But fishing isn't like that. It's something that if it's managed properly, it's better for the fishermen, it's better for the people who consume fish, and it's better for the environment. There really is this optimal point. And so I do think that there's this obvious tragedy of the commons problem, but that once people start to get the sense that that we're all in this together, and it actually is going to be better for me, even as impoverished as I may be, that if I follow the rules, we're going to all do better and actually catch more fish. And so I think there are examples, particularly in the United States, and efforts led by Dr. Lubchenco, I think have been quite successful. And I think as those models move out to the world, you're going to see it's not just a win and lose situation, and that's going to really help.
Great. We brushed on it a little bit earlier, but I did want to talk a bit about the intersection between policy and technology. You mentioned the FAA and drones, and a lot of times we see technology evolving so quickly that it's been tough for regulators to kind of keep up and understand what's coming next. So in that space of IUU fishing or marine technologies, what are some of your thoughts on how technologists or tech developers and policymakers can work better together, or some things that the policymakers need to start thinking about into the future so that we can make the best use of this stuff?
Yeah, and another good example of this is TMDL's, total daily maximum loads. It's a regulated amount of pollutants you're allowed to release in a water body. The way those are traditionally monitored is a water sample once a month, and you analyze it in a lab, and it tells you what your load is. And the regulations have been built around that existing technology. Now that we can do a lot more with sensors, you can get readings every 15 minutes. The regulators are going, what do we do with that information? What if one of the readings is above the TMDL? Do we average these? And so it's just going to take a bit of thought, subject matter experts around the individual topics to design how we can incorporate these technologies into smarter regulations. Just because we've been doing it that way for 50 years doesn't mean we should still keep doing it that way.
Right.
Yeah, I would say that's a good example of where regulations and technology get a little bit out of sync, and a place where there need to be lots of conversations between people developing policy and people developing technology that could help support that policy. I see the other way too. We're identifying places where we want to protect marine areas and we want to declare areas are protected. We actually don't have very good ways of knowing if they're protected or not. You can declare an area protected, but anybody can go in there at any time. Fishing happens. You don't know. And so that's a case where the policy is a little ahead of where the technology is, and those things need to catch up, or vice versa. And as you pointed out, technology is evolving very, very, very rapidly, and it takes time to make policy changes, and there are a lot of people who need to be talked to. So it'd be very helpful to encourage lots of conversation around those areas so that everybody stays a little bit more in sync. I think that's important.
Yeah, I think another model that needs more attention is services as opposed to acquisitions. Sometimes I think that at least in our world, we've seen ships and satellites that exist and have a lot of momentum behind them, and a tremendous, and relative to robots, a tremendous amount of spending. end up sort of being free to the scientists sometimes. So if you're working on a research proposal, getting ship time isn't something that you're necessarily going to have to pay for. That ship existed, somebody else already paid for it. Even if you're the National Data Buoy Center, the Coast Guard actually pays for the ships. You can just maintain your buoys. And so you have these sort of institutionally entrenched technologies, ships and satellites, that then are actually, I think they're great. I'm not arguing that we shouldn't have them, but you don't have the flip side to new things. And so especially in an era of declining budgets, it's really hard for new technologies to find their edge in there, right at this point that we talked about earlier of when it's going to be operationalized. And so I do think there needs to be more thought of that. And I think one way of doing it might be data as a service, where we don't think about the government actually running the fixed assets. Because frankly, if it's high tech, it's going to be obsolete soon. So maybe you shouldn't be buying it anyway. Have people do that, run it as a service for you. I'm not sure the exact schemes, but I definitely think there needs to be more thinking in this area of how to make the government more nimble, more able to adopt new technologies and throw out the old. And some of that might mean not owning it.
Mm-hmm. No, that's a good point. And I think I'm sorry. I was just going to say, I think I've seen another good trend happen in this tech space when it comes to oceans. Years back when people were starting to come up with these new ideas, oftentimes they develop it kind of disconnected from the end user and not really talk to the boots on the water, right? The folks that are going to be taking that data and making something actionable happen out of it, right? And so I think there have been some big failures or pivots and things like that have changed as a result of developing something in a bubble and then trying to get somebody to use it. Whereas now it seems like a lot of the people in this space are talking to the folks on the front line, which is a great thing.
Right, that's exactly what I was going to say. The increased dialogue is critical in this space, I think. On one side, asking the question that Bill posed earlier, which is, what's the greatest challenges out there? So talking to regulators, and so, for example, the marine protected areas is a classic example. We've done this regulation, but we don't have the technology. Conversely, regulators should keep an eye on up-and-coming trends. So what does 2020 technology look like? So there's no point buying technology if it's going to be obsolete by 2020. So that dialogue is really, really critical.
Mm-hmm.
And there are successful strategies for this. There's technology forcing regulations, right? Where you put a regulation out there that's currently not feasible, but possible in the near future, and you push technologies to meet that. Catalytic converters in cars for air emissions is a good example. So there's ways of doing that, but the regulators need to talk to technologists.
And there's the enforcement, the other end of it, which is how do you work with enforcement too. I have sort of a practical story about that on the drone front. We, like many other people, experimented with deploying drones in Africa to fight poachers. And it turns out that many poaching scouting parties in Africa are like 4 or 5 people in a Jeep on horseback. But if you show up with a drone, there's a drone operator, and there's a guy who looks at the screen, and there's a maintenance guy, and there's usually another guy who has to spot to make sure it's not going to run into anything, and then there's usually a guy to help port it all around. So if you had a team of 4 people, and you show up with 5 more in order to try to run it, you've completely failed in your ability to deploy that thing because you've just doubled the cost of the operation and not delivered what you want. And so really going to the end user and understanding their concept of operations, tuning your things so that you fit exactly within how they work, whether you're on the ocean, on a boat, on land, that's really key for any of these technologies. And we see again and again a great technology idea rolled out to support some policy, and then it struggles because it doesn't match with how things actually operate. And so another good place to spend time.
Great. So I have some of these audience questions and some from Twitter. I'm going to start from this one from Twitter and just broadly ask everybody on the panel. So do you see venture capital interest or any opportunity in funding the early stages of some of this marine technology? I mean, we all see VC in the regular tech world and how big it is, but what about the ocean tech?
I think it's just about the only way that unmanned surface vehicles have been funded, frankly. Liquid Robotics was funded by venture capital, and Saildrone, which is right now being used by NOAA, is also being funded by venture capital. So I think it definitely is is a very good place to look. It needs to be linked to profitable business models.
Right.
So it's not going to fund some of the things that are, more on the pure research end, or it probably shouldn't be used anyway on that. It has to be things that actually have a path to giving those venture capitalists a return. Yeah.
And that speaks well to that end product, right? If a venture capitalist sees a way for the thing that's being built to actually having a successful market, you're probably well on your way to getting the deployment to the thing you need. That's a really good sign.
Yeah.
Great. So I have a question from the audience, and it's about something that I talked about earlier, was open source. Do you guys have any thoughts on how to incentivize open source and these types of technologies to broadly bring overall technology costs down and make it lower?
I was going to say, that almost goes against the last question, which is what's the business model? So open source is generally not a venture capitalist dream business model, so it really depends what you want to do with this. I think there's a case in both cases. It depends on the technology and the problem that you're solving to have open source. I think open source data would be amazing. So venture capitalists, you can certainly go for the technology development, but open source data would be phenomenal to have if everyone had it. Good quality data, as you said.
Or known quality.
Or known quality.
That'd be great.
And on an easy to access platform. That's one of the issues I think that we face, is that the data is not that easy to access.
Yeah, data is also a product, right? So there's incentives in certain data management to keep things in kind of a closed way, and so how do you see about getting past that? Like working with companies that own this data and that's how they make their money. How do they come on board?
Yeah, I was going to say that there's open source and then there's open access, which is what you call an open access database. And we spend a lot of time on that. The information the Brain Institute is all open access. You can get companies to open up data for the right need and the right product, provided they either have retention or rights to use it where they need to. I think and it's actually open access is seen as an increasing touchstone in scientific rigor these days, showing how you got your data, being able to expose the large data set from which you draw your conclusions, being able to show the analysis that went into how you produce your product is increasingly key to any scientific endeavor. So I think there probably is a role, particularly in partnerships with government-sponsored research and things like that, to create more open access data.
Yeah, I'd love to see more open source. I think it is sometimes a tough sell, even today, after it's been demonstrated that a lot of companies can be quite profitable supporting open source software and open source efforts. Yeah, so I think it's something that there is a lot of reinventing the wheel going on in a lot of places, and competing standards, and it would be a lot better if we could cooperate a bit on that and move the ball forward.
Right, and I think also open source hardware is a little bit behind in the open source software side of things. There have been very successful companies that have been open source and made money doing it, but the hardware world is trying to figure it all out. Hardware is much harder. So, all right, I want to talk a little bit about what you guys see as over the horizon, or what's your favorite or most exciting technology that's coming up, and where do you think we should be looking into the future?
So I already mentioned this S2S forecasting, and I think that the place, aside from the obvious advances that are happening in data centers and cloud computing that are going to play into that, to our own horn, but it's the ability to collect data in situ. So I think Dr. Lubchenco mentioned that weather models use 90% of their data comes from satellite right now. And that means that it's okay for the weather forecast, which is primarily an atmospheric phenomenon. But when you want to go out a little bit farther, you need data from inside the ocean. And so for us, it's been about, we operate at the surface of the ocean. We can stay there for a long period of time. It's about providing data connectivity to the seafloor. And here, it's not really fat pipes. It's not giant data flows, but just, 1,000 bits per second coming up from the bottom of the ocean can completely change our understanding of what's going on out there. And so the ability to actually connect the remote parts of the bottom of the sea to this system, I think is going to have some pretty profound effects, and it's going to be across domains. So the interconnectivity, it's not just one device, but a system of network connectivity in the ocean.
I think where we're going, what's exciting about ocean science is something that Jyotika touched on earlier, and that is small, inexpensive sensing. Most of the things we're interested in, you need high spatial and temporal resolution. You need to monitor on minute scale and large, vast areas of the ocean. And the only way that's going to happen is through small, miniaturized, inexpensive, almost disposable type sensing tools. There's been a lot of advancements in that, even biosensors that are showing a lot of promise. And that's where I hope we all end up.
Hey, where do I start? No. I think we've all touched on these to some extent, but let's see. So we have drones that can now go out to sea and then operate from air and dive into water. So that's a really nice, interesting new way of accessing remote locations, as well as the robotics and the autonomous vessels. So I think we're looking at a shift in how we can access the ocean. I agree on the biosensor front. I think genetics is huge in DNA. So being able to sample, a water sample and identify what swam through it, even if it's hours later, that's pretty amazing. I did see some studies on looking at fish populations and using that technique. And these are preliminary studies, but that would change how you do fisheries management. So that's really exciting. I think, as I mentioned earlier, with 3D printing, we can do cheaper technologies. We even had a 3D printed casing that went down to 3,000 meter depth. So there's some really great advancements on that front too. So let's see. I think I'll just stop there for now. But there's some really, really interesting technologies that are emerging from other fields. I'd look at material science, graphene. So fields that are outside of our traditional oceanography, and see what we can adapt and pull in from there. Some really fascinating stuff out there.
I think that's a great list. That's good. The things I would add would be,
What did I forget?
the democratization of space data,
Yes.
right? With constellations of small satellites everywhere is
Communications,
really, really important. I think the explosion of computational capability can't be overlooked. I mean, we keep on riding that curve of analytics and computational power that is really changing everything we do today, and connecting things. And I think tying it back, you mentioned that there's a lot of IoT, tiny sensors, there's the space sensors, and then there's that middle tier of drones and mid-level sensors that bridge the gap to put the whole picture together. I think all of those things are really important, so that you'll be able to go all the way from satellites down to nanopore diagnostics in one data set and understand what's going on. I think that's really important.
So I want to get thoughts from you guys broadly. Now, seeing as those great technologies are our future state and where we want to end up being, what's standing in the way? What are the challenges?
Time, money, people. It's all the normal things that have to be done to make hardware actually get there. I do think there is an increasing amount of cooperation and awareness that's accelerating everything. I think that's really important.
Again, thinking like a biologist, I think one of the biggest challenges, we're overcoming some of the data issues, some of the power issues are still there, but we're getting better at. But I would argue biofouling is probably one of the biggest limiting factors that we really haven't made much advances on. Anytime you put a hard structure in any natural water, it's going to start growing. And that limits your sensing ability, limits your ability to move through the water and so on. I mean, if you put a sensor on the Chesapeake Bay right now, you might get 2 weeks of good data out of it before it overcomes to fouling. So finding ways to stop fouling, whether you're a sensor or a ship or a cooling pipe of a power plant, is a big deal.
I think there's a lot of really interesting technical challenges for us to solve, but I think the biggest challenge, particularly when it comes to so-called saving the ocean with technology is one of will. I think, being said quite a bit, 2050, no corals, 2050, more plastic than fish in the ocean. If that doesn't get people to act, technology is a tool. Ultimately, people have to want to use it. And so I think the biggest thing that I'm struggling with is how is it that people aren't more compelled to take action on some of these things. It really does seem to be one more of will. And I know right now we're in a little bit of a bubble here in the United States. We're an anomaly. The rest of the world does seem to be becoming more aware and more interested in solving these problems. And I think that's, if there's a will, there's a way.
So just building on that, and also a couple of technology limitations. I think improving underwater communications, if we could solve that challenge, that would be amazing to have a network of sensors spanning the ocean. And then power, you mentioned power. So that's another technological challenge. But going back to the will question, it is, how do we inspire the general public? Not those of us who are in this room and who are already interested in the oceans, but everyone else. And so to that end, we undertook a piece of work at XPRIZE to look at how the space community communicates to the general public, and how does the ocean community communicate to the general public. And I can talk, that's a different topic though. But one piece though that is technology and connects to that is virtual reality. Virtual reality and augmented reality we've not yet mentioned. There is an example out there if anyone wants to try it. I think that's a really, really great technological way of connecting to the public and getting them interested, whether they live on the coast or not. And once they've experienced that, hopefully they will want to go and do more for the oceans.
Yeah, I mean, I think we're lucky in that we're living in a time where for the general public, technology is cool. People want to get the newest iPhone or whatever it ends up being, right? So it's one of the challenges that we face is how the work that we're doing, how we can connect other people to it, or bring up these issues in ways that you were talking about with apps or other kind of mechanisms and open data and stuff that can get out beyond just kind of the echo chamber and all of us that understand these issues to people who can advocate for it all across the board. So I think we're just wrapping up, and I did want to thank the panel, all very impressive and wonderful people. I think they had a lot to say, so maybe let's give them a round of applause.
I want to thank all of our participants today. Thank you so very much. And thanks again to Bill and the team at Vulcan for their work on Skylight and putting technology into use for conservation. Technology really is a game changer. I think you heard a lot about that this afternoon. And we're trying to find new ways to use technology to engage people with the oceans through Capitol Hill Ocean Week. So I hope that as you walk out of the auditorium that you'll take a chance to look at the sanctuary story map that Esri helped us create for this event. Also, if you haven't had a chance to drop by the virtual reality booth and take a look at how you can dive into our national marine sanctuaries. As part of the premier registration tomorrow, we'll take an even deeper dive and go behind the scenes about how you can use VR to look at conservation efforts and really bring them home to people that can't actually go underneath the surface through a dive. We hope that you'll join us at 3:30 today for what is going to be an exciting panel on emerging leaders and next wave. One of the things that we think is very important at Capitol Hill Ocean Week is to bring new voices and the next wave of leaders who are looking at conservation, climate change, and other issues in very different light. And so also please, during the break, tune in to Ocean Live. Thank you very much, and we'll see you at 3:30.